Welcome to Module 1, Lesson 25, A Fraction as a Percent. After today's lesson, I would like you to be able to write a fraction as a percent of a whole quantity, write a decimal as a percent of a whole quantity, write a percent of a whole quantity as a fraction, and write a percent of a whole quantity as a decimal. So we're going to be doing a lot of converting between fractions, decimals, and percents. So it's really important that we remember percent means per 100. That's really going to help us when we are trying to turn it into fractions and decimals. Those base 10 numbers are really fantastic to work with. All right, so we have example 1, and we are looking at the ratio of cars to trucks, and all the different ratios that we can find here. So I did say the ratio of cars to trucks, but there's obviously other options that we can do as well. So I want you to take a minute and pause, and I want you to find a couple of different ratios from this picture. Okay, when you come back, we'll go over the different ones. All right, so I know that I could have the ratio 3 to 5. There are 3 cars for every 5 vehicles. I could also have 2 to 5. There are 2 trucks to every 5 vehicles. And I could also have the ratios 3 to 2. There are 3 cars to every 2 trucks. And obviously then I can flip all of these as well. I could have 5 to 3, 5 to 2, 2 to 3. All of these are ratios that would be correct, ratios that you can create from this problem. Now, we are going to focus on the ratios that are part to whole. So in this case, part being my 3 and my 2, because the cars make up part of the whole group of vehicles. Trucks make up another part of the whole group of vehicles. And then the whole being all the vehicles. The reason we're going to focus on the part to whole is because when we look at a percent is part of something. So we really want to look at what a percent means and what it's actually representing and understand what a percent is before we move on and use it in different situations. All right, so now here we have the question. We have Sam says 50% of the vehicles are cars. Give 3 different reasons or models that prove or disprove Sam's statement. And then your models can include tape diagrams, 10 by 10 grids, double number lines, etc. So here he says 50% of the vehicles are cars. And then it also says give 3 different reasons or models that prove or disprove Sam's statement. Okay, key terms here, we need 3 different reasons or models, so we can do a combination of those, and then 50% are cars. So first, let's look at this. We're going to make sort of a tape diagram / double number line. We're going to kind of combine the two. So I have my tape diagram, and what I'm going to do is I'm going to show that there are 5 total vehicles. So 1, 2, 3, 4, and that last one is 5. So here I have 0 and I have 0. And I know when I count, since this is a diagram of the vehicles, I know that this is 1 vehicle, 2 vehicles, 3 vehicles, 4, and 5. So here we have vehicles. And on the bottom we have percent. Now, to figure out what each of these is, we have to understand what this picture actually means. Since 5 is the whole group, so 5 is all of the vehicles that we're working with. If I have 5 vehicles, that makes up one whole group. Well, we know that one whole is equal to 100%. So this whole thing right here, percentage-wise is equal to 100%. If I have all 5 vehicles, I have 100% of my group. I also know that I have to divvy out my percents evenly. So since I have 5 sections, to figure out what each section is worth as a percentage, I can take that 100%, divide it by 5, and I get 20%. So each line here is worth 20%, or each box. So we have 20% and 30%. I'm sorry, 40% if we're going by 20s. And then we have 60%, 80%, and then of course we have 100% at the end. Now if I look at this carefully, I realize that I have 3 cars. So I'm going to kind of model this a little bit more. So here's 1 car, 2 cars, 3 cars. So I know that when I have 3 cars, that's 60% of the vehicles. Well, Sam said that there are 50% of them that are cars. And here in my diagram, I see that nope, if I have 3 vehicles, that's equal to 60% of my total. So here we're realizing that we are disproving Sam's theory. The other way I can do this is I can change my percent to a fraction. So I know that percent means per excuse me. I know that percent means per 100. So what I want to look at here is, first I need to look at my value. My ratio that I want to work with is 3 to 5. Okay, so as a value, this is 3/5. So the cars to total value is 3/5. So I know that I want to make this a percentage, and to do that, I have to get a denominator of 100. To do that, I have to multiply 5 by 20, and so I have to multiply 3 by 20. When I do 3 times 20, that gives me 60. And I know that 60 over 100 is 60%. So here, I found out, since this is cars to total, if I look at it as a fraction, or even back as a ratio, if I have 100 total vehicles, 60 of them are going to be cars. And I know that as a percentage, this is 60%. So 60% of vehicles are cars. Again, we are disproving Sam's theory. Okay. And another way that I can look at this, so here we really focused on how many cars we had and how to work with the ratio 3 to 5 and turn it into a value or turn it into a tape diagram. So what we're going to look at now is just what is 50%. Well, I know that 50% means 50 out of 100, which I know can simplify to 1/2. So I know that 1/2 of the vehicles have to be cars in order for Sam to be right. So what I can do is I can take my total number of vehicles, which is 5, and multiply it by 1/2. When I do that, I get 5 over 2, which changed to a mixed number is 2 and 1/2. What this means is, in order for Sam to be right, then only 2.5 vehicles out of the 5 can be cars. Since 3 of them are cars, we don't have half a car just sitting up here. Okay, since 3 of them are cars, we know that Sam is incorrect. So now we've given 3 different ways to justify our response that Sam is incorrect. We showed how the 3 is equivalent to the 60% because it's 3 out of 5, which is equivalent to 60%. We showed how the value can be made equivalent to 60%. And we talked about what 50% actually means and what it equals in terms of this problem. All right, so let's go to the next page. And we have example 2. In example 2, we are looking at a survey that was taken that asked participants whether or not they were happy with their job. Okay, and from here, I want you to go ahead and pause and read the problem. You need to highlight, underline, and box your important numbers. When you come back, we'll make sure you have everything boxed and highlighted and underlined accordingly, and then we'll move on to the problem. All right, so is it important that he took a survey? Not necessarily. So we are going to look at the next part where we see that 300, and actually I'm going to use a different color here so it's a little bit easier to see. 300 of the participants were unhappy, while 700 of the participants were happy. Now I need to give a part to whole fraction for comparing happy participants to the whole. Then write a part to whole fraction of the unhappy participants to the whole. Then I want to know what percent were happy with their job and what percent were unhappy with their job. So important numbers here. It's important to note that there were 700 and they were happy, and there were 300 and that those 300 were unhappy. Okay, and then it's important to note that we want to write part to whole and that we want it to be a fraction, and that we're going to do this twice. Then we also want to know what percent were happy and what percent were unhappy. So we got quite a few things going on here. So make a little note for ourselves that we first know that we need to do fraction, and we need to do a percent for both. And then that those are going to be part to whole. So over here we are going to do the happy, I believe is what you guys have. Yep, there it is. So over here we're going to work with the happy, and then on the other side we're going to work with the unhappy. So as a fraction, since it's part to whole, I know that, well, I'm talking about the participants that were happy, so we're talking about the 700. 700 isn't the total amount of people that were surveyed. 700 people is how many were happy, so they're the part. Well, how do I find the whole then? Because 300 can't be the whole because we surveyed more people than that. Well, since 700 were happy and 300 were unhappy, there's only 2 categories. It doesn't give us anything else here saying no answers or neutral. It just says that there are 700 and 300. So what I can do then is I can add my 700 and 300 off to the side and find out that there were 1,000 participants. So 700 out of 1,000 were happy with their jobs. Now, since I already found the whole for happy, that doesn't change for the unhappy. There's still 1,000 people that they surveyed, but now it's only 300 people that were unhappy with their jobs as compared to the 700. Right, so what we're going to do now is we're going to turn this into a percent. Well, a percent is over 100. So we need to be really good at finding numbers and figuring out how they work with 100, how to get them to 100. Well, I know that I have 1,000. And I know that 1,000, if I divide it, can go down to 100. So if I divide by something, it should give me 100. Well, since I'm eliminating 1 0, I know I have to divide by 10. I divide by a 1 with 1 0 because that's what I'm eliminating. What I do to the bottom, I do to the top. So again, it's going to eliminate 1 0. So I get 70 out of 100. So since it would be 70 out of 100 for the happy people, then we know that 70% of those people surveyed are happy with their jobs. Now over on this side, we can do the same thing. Well, if you look at this, you have two numbers that they have a number in front and then they have a bunch of zeros. Well, since we want to get to 100, I know I just have to eliminate a 0 here. And what I'm doing is I'm actually dividing by 10. So I can show this by saying, all right, divide by 10 on bottom, divide by 10 on top, and I end up with 30 over 100. Now that it's over 100, and I know that percents mean per 100, so 30 per 100, so 30% of people are unhappy with their jobs. And again, we're going to create a model just to justify our answer here. And I really like this kind of tape diagram. It really seems to help us out a bit, and it especially allows us to visualize what's going on. So there is no way that I would expect you to draw 1,000 boxes. That's just silly. So we're going to take 1,000 and break it down by hundreds. So 100, 200, 300, 400, 500, 600, 700, 800, and now I'm just one box short. So we'll go ahead and make it just a little bit longer. And 900 and then 1,000. Now, why would I have chosen to split it by 100s? Well, first of all, hundreds are easy to work with and they're easy to count by, and they're big enough where we can get to 1,000 fairly quickly. So up here would be my people surveyed, and down here would be my total. Oops, total. There we go. Well, now I don't have to have, it's not that the people surveyed would be on top. What it's actually going to be is that we are going to look at our percentages on top. Okay, and then here we have total people on bottom. So I know, again, I said we have 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. So here's all of our people. So now we said that the whole group, that all 1,000 people, would have to be equal to 100%. So then here, this would be 100%. And then now, since we know it's broken into 10 sections, this is really easy for us to say, oh, well then this would be 90%, 80%, 70%, 60%, 50%, 40%, 30%, 20%, almost there, and 10%. All right, so what I can do now is I can justify my answer by looking at how many people I have and what percentage they line up with. So if I look at the number of unhappy participants, we know there were 300. And I know that 300 lines up with the 30%. So what that means is 300 out of the 1,000 is equivalent to 30%. So I could say 30% of people were unhappy with their jobs. Now, there's two ways to look at this next part. Since we know that these boxes are already used, we know that the only thing left are these boxes here, and these would have to be the people that are happy with their jobs. So here we have, even though this is 300, we already used those 300 people, so we'd start counting over. And you'll notice that, well, there's 10 boxes total. We used 3, so I only have 7 left. Each box is worth 100, so this must mean that there are 700 people. And what we had up top was that there are 700 people that were happy with their jobs. So you can use the box to kind of work it that way and say, okay, well, that means that there are 7 boxes left, which means there's also 70% left. So the percent of happy people has to be 70%. Or we can go back to the beginning and count and find where 700 is. So we get to here, and we see that that lines up with 70%. Since it lines up with 70%, that tells me that 70% of the workers or the people surveyed were happy with their jobs. Right, so now what I want you to look at is how would we represent this as a decimal? We're going to just take this one step further, and we know that with decimals, we have base tens again. So we have tenths, hundredths, thousandths. So if I look at this denominator, I know that this denominator tells me that my answer has to end in the hundredths place because it's hundredths as a fraction. I know the hundredths place is 2 places after the decimal. So my last number has to go in that last spot. And then I put the 70 or the 7 here. So I have 70, but now I have no numbers left, so I have 0. So as a decimal, we would say 70 hundredths. All 3 of these pieces are equivalent. So if we can go from fractions to decimals, we should be able to throw in now how to change that to a percent. It's especially nice with decimals because all decimals are base 10, and so you can divide or multiply them to get you that denominator of 100 to make it easy to convert to a percent. All right, so in exercise 1, we are looking at Renita, who claims that a score of 80% means that she answered 4/5 of the problems correctly. She drew the following picture to support her claim. Is she correct? So first, let's not even worry about the second part yet. Let's look at the important information. So 80% means that she answered 4/5 of the problems correctly. Remember, percentages tell us what we got correct. When you get something back, a teacher doesn't say, oh, you got a 10% because 10% were incorrect. No. We tell you you got a 90% because you got 90% of the problems correct. So now we want to know, is she correct? My important numbers here would be 80% and 4/5. So what I'm going to look at here, and she already colored it in. So you have 100. So this is a block of 100. And you can double check that by looking and seeing that it's 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. If I take 20 times 5, that gives me 100 total blocks. And then inside of it, she shaded 80 of them. Well, the visual representation here shows me that here's one row, here's 2 rows, 3, 4, and 5. So she purposely drew the 5 different rows to show that if she colors in 80, she colored in 4 full rows of boxes. And she covered in 4 full rows of 5. So since she colored in those, so 80 here was equal to 4 out of the 5 rows, which means that yes, it would be true to say that she got 4/5 of the answers correct. Because in here, she has 4, so look at these as all the problems she did correct. So she has 4 full rows out of the 5 total. So even if you blocked the rest of this out because they're all the same, so it's 4/5, 4/5, 4/5, 4/5. Well, all of that together is going to be equivalent to 4/5. So is she correct? Yes. Okay. Why or why not? Well, I can also look at it in terms of 4/5 as a fraction. I want to turn it into a percent, so I know I have to multiply it by something to get to 100. We've been working a lot with 5, so we know that we have to multiply by 20, which we can also see here from her table, from her grid. So what I do to the bottom, I have to do to the top, and I get 80. Well, it's 80 over 100, which I know is equal to 80%. So yes, Renita is correct. And then looking at this, how could we change Renita's picture to make it easier for her to see why she is correct or incorrect? Well, I want you to kind of think about this. What would you do? Okay, what I might do is I might actually look at this and maybe change the picture so that there is a percent scale down the right side showing 20, 40, 60, etc. So showing that since this is 20, one row is equal to 20, I could say over here that it's 20% and 40%, 60%, 80%, 100%. And then I could see that my 4 full rows is equivalent to 80%. I could also change the picture to just be smaller and have just 10 strips and have 8 of those 10 strips shaded in, and then know that, well, since it's 8 out of 10, I would have to look at that in terms of 5 and reduce it to get to 5. So there's different ways to look at this. Don't always feel like you have to draw this huge grid because a percent is out of 100. If you can make a grid that is equivalent to the hundredths or hundreds, you can also represent percentages without using 100. You can use tens, fives, it all just kind of depends on what you're working with. So now we're getting into a little bit more, and we have exercise 2. And we are going to use the tape diagram to answer the questions. So I have 80% is what fraction of the whole quantity? Well, first we know that we want to look at 80% is what fraction of the whole quantity. So if it's a fraction of the whole, I know that I'm looking at a part to whole fraction. So looking at my diagram, I know that my whole group consists of 5 pieces. So I know that my denominator has to be 5. If I look here at my 80%, I can see from the diagram that 80% lines up with 4 pieces. So having 4 out of the 5 pieces means that I would have 80%. Now I want to know, so I have 1/5 is what percent, so I have 1/5 is what percent of the whole. Well, the whole is 100%, which makes sense, and I only have one piece. So if I look at my one piece and see where it lines up, I see that it lines up with 20%. So I know that it is 20%, so having 1 out of 5 pieces is having 20%. So it's like saying I had 1 out of the 5 pieces of cake. I ate 20% of the cake. 20% being this right here, so it's just part of the cake. It's not the whole thing. It's not 20 pieces, it's 20%. So what I'd like you to do now is I'd like you to pause and I'd like you to try the next two on your own. Don't forget to underline and box. We're not highlighting in this case because it's just giving us 4 different questions. And when you come back, we'll take a look at your answer. All right, so here I should have found that 50% was important, and I want a fraction of the whole. So again, I know my whole is 5, and it's not 100 because 100 is my percentage. Okay, so percentage would stick with those questions that are asking for the percent. The whole is how many I have total. It's what's opposite of those percentages, and in this case, I have 5 total of whatever it is. And if I have 50%, well, 50% is right here. So we have to do a little bit of figuring. Since I know that to go from 40 to 60, it's 20 units. Okay, so from here to here, it's 20 units. Then I know that, and I know 50 is 10 between, so there's 10 units between 40 and 50. And then I also know that there's 10 units between 50 and 60. So I know 50 is halfway between 40 and 60. So I know that whatever number this is has to be halfway between 2 and 3. Well, we can look at this logically and say, well, halfway between 2 and 3 would have to be 2.5. But if we're confused, what we can do is we can look at 2 and 3 and say, okay, well, I want to know if there's 1 between 2 and 3, and I only want half of that. I multiply and I get 1/2, and then I add that 1/2 to this 2 where I'm starting at, and I get 2 and 1/2. So 50% is 2.5 fifths of the quantity. I could also say that it is, if I multiply it by 10, I can also say that it is 25/50ths of the quantity if I were to break these down even smaller. Or I could say that it's 1/2. Then 1 is what percent of the whole quantity? Right, so 1. Well, that doesn't mean this. This is 1/5. This is 1 out of 5. That is a fraction. So this 1 is 1/5. It's not 1 whole. 1 whole is actually the whole group. So this 5 is actually equal to 5 out of 5, which is equal to 1. So 1 as a percent of the whole is actually 100%, not 20%. You have to remember that here we said that it was 1/5. So this 1 was just that top part of our fraction. Okay, well here it's not, we don't have a fraction, we just have a whole number. That whole number represents our whole group. All right, moving along to exercise 3. So now I have Maria who completed 3/4 of her workday. And we're going to create a model that represents what percent of the workday Maria has worked. So again, important information is 3/4 completed. And I want to create a model that represents what percent of the workday she has worked. So now, since it says the workday that she has worked, that tells us that we're looking for what she's already done. And again, so completed 3/4 of her workday, create a model that represents what percent of the workday Maria has worked. So you have to think of the fact that it says worked means it's already done, meaning she's completed it. So what I'm going to do here is I'm going to look at it and say, all right, well, since it's 3/4, then my tape diagram should have 4 pieces. So 1, 2, 3, 4. So here is 0 parts of my workday and 0%. Here's 1 out of 4 parts of my workday, 2 out of 4 parts of my workday, 3 out of 4 parts of my workday, and 4 out of 4 parts of my workday, which would be equal to the whole day, which is 100%. Again, you have to remember you have to look at these as fractions. So this is 4/4, 3/4. It's not just 3, it's 3 as a numerator out of the whole, which in this case is 4. Well, since I have 4 and I need to break up my percentages evenly, I have to take 100% and divide it by 4, which I know gives me 25. So I have 25%, and then I would have 50%, and then 75%. So now, since Maria completed 3/4 of her workday, so on top we can see that there's 3 out of the 4, and that is equal to 75%. So I've satisfied the first part. It asks me to create a model to show how much of the workday she has worked. But now I want to know, well, how much didn't she work? How much is left? Again, I can look at this one of 2 ways. I can look at the difference between 75 and 100. So I know to go from here to here. So I can take 100 minus 75. And I know that it's going to give me 25. So I know that this one box that's left would be 25%. I can also look at, well, I have one box left, so let's look at what 1 lines up with, and on our diagram, 1 lines up with 25%. Since each of these pieces are equal and I'm only looking for one of the boxes, I can know that 1 is equal to 25%, so this box, which is worth 1, is also only worth 25%. Okay, so as my answer, because it wants to know how much does she have left, as my answer, I would say Maria has 25% of her work day left. And again, I wrote it as a percent because it says, what percent of her workday does she have left? Now, there wasn't any important numbers, or there weren't any important numbers in here because we found all of our numbers up on top. Okay, now here, let's look at the next part. How does our model prove that answer? Well, we already kind of talked about this. We showed that we know that between 75% and 100% is 25%. So I know that that piece here, since this much has already been used, so since this much has already been done, I know that that box that I have left is equal to 25% by either subtracting my percentages or by checking to see that one section, or 1/4 of the boxes, is equal to 25%. All right. Exercise 4 with Matthew, who completed, and I apologize, this got taken out here, 5/8 of his workday. What decimal would also describe the portion of the workday he has finished? So now we're looking at something a little bit differently. In order to turn a fraction into a decimal, I divide. So because it's 5/8, I can't change that easily. So since I can't change that easily, I know that this is a division problem. It turns into 5 divided by 8, which is going to be 0 and 25 thousandths. Okay, so, and I apologize, we keep kind of skipping ahead here. What decimal would also describe the portion of the workday he has finished? Completed 5/8. 5/8 is important. Decimal, finished. Okay, so now what I want to look at is how can you use the decimal to get the percent of the workday? Well, I know that this isn't a number that ends in hundredths. It ends in thousandths. So if we actually look at what this is as a fraction, I know that as a fraction, this is 625 over 1,000. Now I know it doesn't work nicely, but we know that when we divide with base 10, that we actually are just moving the decimal left and right. So here, to go from 1,000 to 100, I have to divide by 10. And what I do to the top, I do to the bottom. So here I have 100. And now on top, if I take 625 and divide it by 10, and I'll show you with long division, 10 goes into 62 6 times. And I subtract and I get 2, and I bring down my 5. 10 goes into 25 twice, minus 20. Now, I don't just stop here and say 62 and 5/10. No, what we're going to do is to keep dividing, I add a decimal, and then I bring it up to my answer right away because my decimal goes straight up. And then now I can add a 0 and bring that 0 down. Okay, as long as we add that decimal, we can add that 0. And I know that 10 goes into 50 5 times. And I subtract and I get 0. So 625 divided by 10, again, the decimal goes at the end, and I swing it 1 to the left, which gives me the same answer. So this would be 62 and 5/10, which I know then as a percent, it's just my numerator. So it is 62 and 5/10, or 62.5%. And that's okay. We can have half percentages. That's not a problem. Doesn't look very nice, but it's still correct. All right, so here we have convert the conversions from fractions to decimals to percents. So I'm going to do the first one with you, and then I'm going to have you try the rest of them on your own. And yes, we're still going to check your answers. But again, when you're doing this, so you have 1/8. Well, 1/8 isn't a nice fraction, so we're going to divide it. So I do, and I can show my work off to the side, 1 divided by 8. And I can type this into a calculator and find that I get 0 and 125 thousandths as a decimal. Then now, as a percent, I know that, well, I know that it'd be 125 over 1,000. So I know that that decimal has to move one place to the left in order to, so if I write this as a equivalent fraction here, so 125 over 1,000. And when I divide them both by 10, I get 12.5 over 100. So then as a percent, it would be 12.5%. Okay, and I want you to see if you notice anything with the decimal and how it moves or may move to create a percent. So go ahead and you're going to pause and try the rest of the problems on your own, and when you come back, we'll check your answers. All right, so here's a fraction. You should have 35 hundredths, but we also want to simplify, and I know both can be divided by 5, so it's actually equal to 7/20ths. And then I know that since it was 35 over 100, that my percentage was 35%. Now here I have 84 and 5/10%. So I know that I have to put that over 100. What I can then do is to get rid of that decimal, let's move that decimal. So let's multiply by 10 to get rid of that decimal and multiply by 10. So I get 845 over 1,000. Don't worry about simplifying it from here. What we want you to be able to do is we want you to be able to take this percentage with a decimal and put it into a fraction and then get that decimal out of that fraction. So then now what I can do to change it to a decimal is, since my denominator is 1,000, I know that my decimal has to end in the thousandths place, which is 1, 2, 3 spaces after the decimal. So this last number has to go at the end. Then I can place the 4 and the 8. Since I don't have any numbers left, I now pass 0 or place 0. And since this fraction is 845 out of 1,000, there is no whole number. So I shouldn't even have a whole number for my decimal. Next, I have 32, and I'm sorry, it should be 325 over 1,000. Getting ahead of myself here. When I divide them both by 10, I know I get 32.5 over 100, which is now going to make it easier for me to change this to a percentage, because I know that it's just my numerator, which is 32.5%. Okay, this is fairly simple. You just have to realize and be confident in, my number looks a little bit funky, but that's okay. So be confident. Okay, know that what you're doing is correct as long as you're following those correct steps. Change it to a base of 100. Divide, multiply, check your answer with a calculator. That's okay, but you need to be able to do it and show the work to show you know the understanding. So now here, I know that I have 2 25ths. Since it's 25ths, I know 25 can multiply easily to 100 if I multiply it by 4. And what I do to the top, I do to the bottom. So I get 8 over 100. Since my denominator is 100, I know that my decimal has to end 2 places after the decimal. So this 8, which is the only and the last digit, has to go here, which then means that I have to have a 0 as a placeholder, and I do not have a whole number. So my decimal is 0.08, which is equal to 8 hundredths. So when you say your fraction and your decimal, they should sound the same. And then as a percent, since it's 8 over 100, I know that it's 8%. All right, so for the last exercise, you're going to choose one of the rows from the conversion table in exercise 5 and use models to prove your answer. So what I want you to do here is you're going to choose any one of the 5 conversions, and you're going to choose a model, whether it be showing how fractions change to decimals, whether it be a double number line and showing me what that 25% is equal to, 5, or looking at 100% over 20 because it's 7/20ths that you're looking at. So if you're looking at 7/20ths, well then on the bottom would be 20 as your whole, and on the top would be 100% as your whole, and figuring out how everything else plays out from there. Okay, so I don't care what you use to justify it, but you need to justify it and it needs to be correct. And you can choose any of the above examples. Take your time. Even if you're not sure, try. See if you can draw something or show the math or the work to justify your answer. As always, if you have questions, make sure to write them down so that way we can go over them in class.